Please open to page 288 in your student journal. In section 9.3, we're going to continue working with our quadratic equations. And remember, quadratic equation means the highest exponent on the variable is a 2. We're not going to be graphing our quadratic equations this section. Instead, we're going to be solving them. And the awesome thing is, we can use the same steps we already know for solving linear equations to help us solve quadratic equations. The only new thing we need to learn is how do we solve when our variable is squared? So how do we undo squaring something? Or in other words, what's my inverse operation for squaring something? And the answer is, I take the square root. If I take the square root of x squared, I'm down to x. If I take the square root of 9, I get 3. Remember, square root, we're trying to find what number times itself will give me 9. Now, the other thing is, though, when we take the square root of a number, positive 3 squared will give me 9, but so will negative 3 squared. You might be thinking, Miss Golly, I'm not buying it. When I put the square root of 9 in my calculator, it just tells me positive 3. Well, let's check our solutions and see if they work. If I have 3 squared, does that equal 9? Yes, it does. If I substitute negative 3 in and I square it, and remember in your calculator you have to put parentheses around that negative 3 before you square it, this means negative 3 times negative 3. Negative times negative will give me a positive. So both solutions work. That's going to be one of the big differences for us from linear to quadratics. Linear equations are going to have one solution for you. Your quadratics might have 2 solutions. You can write this x equals 3, x equals negative 3, or one new little piece of notation for us, we can write it together using a little plus minus sign. Using the little plus minus sign is going to be a little bit quicker for us, but I will accept either way. So here's an example of solving a quadratic equation using square roots, and we had 2 solutions. Let's take a look at another one. What if we have x squared equals 0? Well, in order to solve, to undo that squared, I have to take the square root, and whatever I do to one side, I have to do to the other. Square root of x squared will give me my plain x. Now the square root of 0 is 0. It doesn't matter if I have a positive 0 or negative 0. They mean the same thing. 0 doesn't have a sign. So here's a case where I solved and I just got one solution. Let's take a look at one more example. Let's have x squared equals negative 4. To undo my squared, I take the square root. Square root of x squared gives me x. The square root of negative 4. I know a lot of you are saying, Miss Golly, it's got to be 2. Well, let's put 2 in and check. Two squared, does that equal negative 4? 2 squared is 4. That doesn't equal negative 4. 2 doesn't work. So maybe you're thinking, Miss Golly, well, square root, let's try negative 2. Now here's where we have to be very careful when we put this in our calculator. Negative 2 squared is positive 4. So negative 2 doesn't work either. So here's a case where I actually have no solution. We cannot find the square root of a negative number. Because whenever we square a number, the result is positive. Whenever we square a number, the result is positive. So our three possibilities when solving a quadratic equation using square roots: we could have two solutions, one solution, or we might not have any solutions. Those are our three possibilities. So now let's continue on. Let's turn to the next page, page 289, and let's continue solving our quadratic equations using square roots. Let's take a look at number 1. I know right away some of you are thinking, Miss Golly, let's go ahead and take the square root so we can get x all by itself. Well, before I can take the square root though, I can't take the square root of this whole side. I don't know what the square root of x squared plus 49 is. I don't know what that is. So we have to use our knowledge about how we solved our linear equations. We need to get that x squared by itself before we can take the square root. So taking the square root is going to be the very last thing that we do. So let's move 49 to the other side. Right now it's a positive 49, so to move it to the other side we subtract it. Just like we would do if this were just x instead of x squared. Now that I have x squared all by itself, now I can undo that squared by taking the square root. X equals, now here's where we have to stop and think. I'm trying to take the square root of a negative number. I can't do that. So we're not going to have an x equals, we're going to have no solution. Remember, I can't take the square root of a negative. I can't find a number when I put it in for x squared that I can square it and get negative 49. Anytime you square a number, the result is positive. Let's crank things up just a little bit. Let's look at number 7. Remember, before I can take the square root to get rid of that exponent of 2, we have to get the x squared by itself first. So pretend like that's just an x to the first power and try to get x by itself. Solve for x. So for subtracting 49, we're going to add 49 to both sides. So we're left with 8x squared equals 200. Next, again, we want to continue getting x squared by itself. This means 8 times x squared. Divide both sides by 8. Now I'm left with x squared equals 25. Now I have my x squared, that squared term all by itself. To undo the squared, I take the square root. Now I'm left with x equals, now I'm taking the square root of a positive number. So that means x could equal positive or negative 5. So this is one of those cases where I have two solutions. If you don't like the plus minus, you can write out the positive and negative 5 separate. But yes, you do need both answers. You need both solutions. Well, let's take a look at number 12. Same idea, we need to get that x squared by itself first before we can do the square roots. Use our same steps you guys have used for the last how many years solving equations. I want to move my 16 to the other side. Right now it's positive, so to move it to the other side I subtract. I'm left with negative 2x squared. 16 minus 16 is 0. To get rid of this negative 2, we're going to divide both sides by negative 2. I'm left with x squared equals 0. Undo the squared, I take the square root. Square root of 0 can only be 0. I don't want to do the plus minus because 0 doesn't have a sign. So with example 1, example 7, and example 12, we've seen a case where we've had no solution, we've had 2 solutions, and 1 solution. Those are going to be our 3 possibilities when solving quadratic equations. If we look at number 15, just a little bit different look at things, now it's not just an x squared, now we have this whole expression in the parentheses being squared. Since that whole expression is being squared, to undo the squared, we take the square root of the entire expression. Taking the square root just gets rid of the squared. The 2x plus 7 doesn't change. But what we have to keep in mind though, when we take the square root, we're going to have that plus or minus since we're taking the square root of a positive number. Now in order to solve this, don't let the plus minus sign bother you. Split it apart. Positive 7, negative 7. Now all you have to do is solve those 2 little linear equations. Subtract 7 from both sides. We get 2x equals 0. Divide by 2. X equals 0. Subtract 7. 2x equals negative 14. X equals negative 7. So we do have 2 solutions, but in this case it's not just a plus or minus of the same number. We had to take the square root as our first step instead of our last step. Let's take a look at one more of those where we have a whole expression being squared. Let's look at number 16. In number 16, I have an x minus 3. The whole expression's being squared. But I have a 16 out front. I know it's very tempting when we see a number in front of a set of parentheses to go ahead and try to distribute. But we cannot do the distributive property here. We cannot multiply because that expression's being squared. What's in the parentheses is being squared. We can't take the square root right away though because of this 16 out front. So to move this 16, it means 16 times the x minus 3 squared. So to undo multiplying by 16, I divide by 16. The 16's on the left simplify to 1. I'm left with x minus 3 squared equals, and now 25/16, that doesn't work out super pretty. So I'm going to just leave it as 25/16 for right now. Now I have my x minus 3, that expression squared is by itself. Once I have that squared item by itself, now I can take the square root of both sides. On the left side, we just end up with x minus 3. On the right side, the reason why I left it as this fraction, I know the square root of 25 is 5, and I know the square root of 16 is 4. Could you have created 25/16? Could you have made it into a decimal and taken the square root of the decimal? You sure could have. I took the square root of a negative, so I'm going to do a plus or minus. So we're going to have x minus 3 equals positive. I'm going to go ahead and change this into a decimal. 1 1/4. And x minus 3 equals negative 1 1/4. Solve each equation. So we have x equals 4 1/4 and x equals 1 3/4. There's our 2 solutions. Now the last 5 examples we've done, they've all worked out very, very nice. Every time we took the square root, we either got an integer or a nice terminating decimal, like a fourth or 3/4. Let's just take a look at one example. Let's look at number 21. Just one example that doesn't work out to be perfect. To get x squared by itself, I have to subtract 25 from both sides. X squared equals 24. I know my next step is to take the square root of both sides to solve. We're going to get x equals, we're taking the square root of a positive number, so we do a plus minus in there. But now the square root of 24, I pop that in my calculator, and I don't get a nice whole number. I get 4.898979, a whole bunch of other junk after it. So what we will do when that happens, we're going to round our solutions to the nearest hundredth. So this would be plus or minus 4.90. And that's okay. Sometimes they don't work out perfect. I'd want to just make sure you saw one of those. The last example I want to look at with you is number 25. Ball is dropped from a window at a height of 81 feet. The function h equals negative 16x squared plus 81 represents the height in feet of the ball after x seconds. How long does it take for the ball to hit the ground? Remember, when something is on the ground or hitting the ground, its height is 0. So if it hits the ground, that means our h is 0. So we want to substitute 0 in for the h and solve our equation for x. So if you notice, we have just a plain old x squared. Subtract our 81 from both sides. Negative 81 equals negative 16x squared. I cannot take the square root yet. I still have negative 16 attached to that x squared. So we're going to go ahead and divide by negative 16. X squared is now by itself. I can now take the square root of both sides. I'm taking the square root of a positive number, so I'm going to have my plus or minus. And square root of 81 is 9. Square root of 16 is 4. If you want to work with decimals, guys, that's okay. We would just have a plus or minus 2.25, so 2 1/4. Now with all the other equations we've worked, we would have stopped here and said x equals positive or negative 2 1/4. But we have to answer the question. It says, after how long does it take for the ball to hit the ground? So how many seconds? The negative doesn't make sense here. So the answer to this question is 2 1/4 seconds. We don't want the plus or minus because the negative doesn't make sense for time. At this time, I'd like you to go ahead and try out your progress check. Feel free to use any of these notes that you'd like.